Hello there and welcome to another blood transfusion CPD talk. So this is going to be our first ever quarterly transfusion update. The purpose of this talk is we're going to try and do a regular one, and we're going to be trying to go through a couple of interesting case studies, review a couple of recurrent CAPAs or audit findings, as well as bring in an example of positive learning. So quite often when we're talking about reflecting on an issue or something that's happened in the lab that we have to learn from, we end up talking in the negative sense. So somewhere where we've made an error and we need to learn how to make sure that doesn't happen again. But really, one of the things we need to be emphasising is when we're doing something really well, whether that be just following a genuine procedure that's already in place and therefore having a good impact on the patient's experience, or it being someone going a bit above and beyond and therefore catching something that you wouldn't catch normally. So in future, if you come across any situation where someone has gone above and beyond or done something that has positively impacted the patient or your workload, or you come across any interesting case studies, then please leave some information on your senior's desk or send me an email so that we can try and include them in future. So we're going to start with case study number 1. So this is from a couple of years ago now. Basically a patient who is female was initially identified as A positive with no antibodies detected. We then transfused 2 units of A positive red blood cells. On the second transfusion, we got a phone call saying we think this patient is having a transfusion reaction. So the lab staff tell them to stop transfusing the unit they're in the middle of transfusing and to send it back and ask for the post-transfusion samples. When we receive these post-transfusion samples, we start the transfusion reaction investigation. The pre-sample comes back with a positive DAT. At our hospital, if the patient has a positive DAT, even if it was positive in the pre-sample, we are currently sending them away for further testing to investigate the possibility of there being a hemolytic transfusion reaction. So, with the exception of the positive DAT, all of the testing on the pre-transfusion sample was as expected. So all of the details matched, the blood group matched, but the post-sample had a very interesting result. We ran the blood group and the anti-D results came back as being mixed field, which doesn't really make sense since we've transfused them with RHD positive red blood cells. So why would it now be giving a mixed field result? We ended up getting a repeat sample and the same thing happened. Stuff away to the NHSBT. The report that we got back basically stated there were no clinically significant antibodies, that the red cell unit that we had sent back to them showed that it was compatible and there wasn't any indication of a hemolytic transfusion reaction. They didn't mention the difference in the blood grouping results from the pre and post transfusion sample. So in the lab, we made the decision to follow this up. Because we hadn't got that second unit of blood back from, well, it was the first unit that was transfused, but obviously we didn't get that unit returned to the laboratory because they were querying a transfusion reaction with the second unit of blood. We couldn't confirm that the blood group of that unit was actually what was on the bag. So what we did is one of the seniors at the time emailed the NHSBT to ask about it. So this is the email that was sent. As part of the process of investigating a suspected transfusion reaction, we have found mixed field reactions in the RHD type of our patient's post-transfusion sample and a subsequent sample, despite the fact that she and both the units transfused are known to be RHD positive. We have been able to type and confirm the blood group of the patient's pre-transfusion sample and the unit which was returned, but she received a further unit which has been discarded, so we're unable to confirm the group of that one. We are interested to know whether the donor could be a weak RHD positive, as this seems the most likely explanation at the moment for the discrepancies. And we'll analyse the samples from the bottom of the sample tube, so that's where the older donor cells are usually concentrated. This is just an interesting side note. That last sentence is why when we're doing a transfusion reaction investigation, we mix the samples to do a DAT. It's to ensure that all of the older red cells and the newer red cells are mixed and we get a proper indication, representation even, of the DAT. Because if you were to take it just from the top or just from the bottom, you might just be detecting the newest transfused cells or the newest patient cells and therefore not get an accurate result. So we then got an email going back to the case study. They've actually said that this patient is most likely a partial D or a D variant, so not a weak D. So this is a very interesting road to go down. Obviously, in the laboratory, if you get a patient that you send off to NHSBT and they do the blood grouping and they tell you that the patient is a D variant, we call them RHD negative. That is because that patient, the antigens on their red blood cells are missing epitopes of the D antigen. Therefore, if they are transfused with RHD positive red blood cells, they could become sensitized to those and create allo anti-D. However, if the patient has donated blood, then that blood would be called RHD positive because it's still got some of the epitopes expected of the D antigen. Therefore, if you were to transfuse that to an RHD negative patient, that patient could create some form of allo anti-D. But if you were to transfuse it to an RHD positive patient, then obviously there's no risks of that patient creating any allo antibodies to the unit. So it's very interesting to think about how it's sort of switched around in terms of donating blood and us testing it in the laboratory. It's also a prime way of showing that the reagents that we use in the hospitals are not as sensitive as the ones used in the donor centres, because obviously they've managed to pick it up and tell that it's a D variant, whereas for us we would have just called that patient D negative. So we're going to move on from that case study now to the second case study. So this patient has presented with the following blood grouping results. So this has been tested manually now. So someone has looked at the analyzer result, seen that there's a discrepancy and done a manual test. So if you have a look at it, the forward group indicates that they are A positive. However, the reverse group would indicate that they are a group O because they are positive for the A1 cells and the B cells. So they've got antibodies for A and B. They also have come up positive with screening cell 1 and screening cell 2, indicating that they have some form of allo antibody. So as I go through this case, I'm not going to spend too much time on the grouping discrepancy as in how we would investigate it, because I've already done a separate CPD talk on that you can find on the YouTube channel and that I have linked in the description below. So the panel was put on and it looks like this patient has an allo anti-big E and an allo JKA, but M and S cannot be excluded. The interesting thing about M and S is that they are, well, M especially is more likely to be a room temperature acting antibody, which can cause discrepancies in the blood group. But looking at the actual reactions, it doesn't look like it matches the M or the S particularly well. So this was sent off to the NHSBT. This patient is an A2 patient though. So they have a variant A, which is why they are coming up with the grouping anomalies. It basically means that they can produce anti-A1, as you can see they have, which means although they come up looking like an A positive patient, as has been stated here, if you were to give them group A red blood cells to transfuse, you would cause a transfusion reaction because the patient has the antibodies to those red blood cells, because the majority of group A is group A1. Therefore, if you look at the end, it's saying to select group O blood as opposed to group A, so this patient would have to have group O indefinitely. M&S were completely excluded, so they were just a coincidence. The DAT was completely negative as well, which again, if you look at the talk on grouping anomalies, it has a bit more information on that. So yeah, this slide is basically going through what I just mentioned. It's really, really important if you have a grouping anomaly to fully investigate it. And if you can't resolve it in-house, ensure that you have updated the LIMS system in a way that shows this patient should have group O red blood cells until the anomaly has been resolved and it has been confirmed that they are able to have their own group, whichever group that might be. So now we've gone through both those case studies. They're both interesting in their own way, and they're not something you come across very often. We're going to move on to some CAPAs. So I'm not going to spend very long on these. They happen all the time because, again, we are only human. But they are recurrent. They happen very regularly. So we're going to start with not recording temperatures. So this is more prevalent at Medway because we don't have to tell her. We've got not signing checklists, and then missing patient details when booking in. So all of these are basically down to not paying enough attention or not being aware that something needs to be done. So we're going to go through why it is important for us to be doing these and how these can have an impact if they are not properly performed. So starting with the temperatures. At Medway, we don't have something like Tutela to be able to monitor the fridges and the freezers and tell us when they go out of temperature. We do have an alarm system in place, so we should be able to hear it when the fridges or freezers go out of temperature, and we should also have a phone call from switchboard if these are the fridges that hold blood components. If they are reagent fridges, then they just have the audible alarm on them. So if you aren't in the vicinity, say for example you're on a night shift and you're in haematology instead of blood transfusion, then you might not be aware of it immediately. Obviously, we test the alarm systems regularly, once a week actually. This is to ensure that they are working, just to make sure that we do actually get notified properly. However, we could test them on a Wednesday and they could break on a Thursday if we were very unlucky. And we won't be aware of that for a whole week. So it's very important that we are recording those temperatures so that we have proof to show that yes, this fridge or freezer was in temperature at that time. It is BSQR requirement to have the properly recorded temperatures. And there is a chance sometime in the future, if we have an investigation go on about a transfusion of a blood component, if we can't prove that we have stored that at the correct temperature, then we would be liable. So that's why it's just really, really important that we are recording the temperatures. In terms of the reagents, if they go out of temperature and we don't notice, the biggest issue with that is that they're not going to work as expected. So if it's red cell reagents and they've gone out of temperature and we haven't noticed it because we haven't been recording those temperatures regularly, then we could end up missing antibodies because the red cell reagents have deteriorated and aren't picking them up. So it is very, very important for us to be checking on these and to, if you haven't had the time to do it on a weekend, or most often it's bank holidays that people forget, then it's just important to hand it over and let the next person know, oh look, I'm really sorry, it's been really manic, or oh, I completely forgot. So if you just check all of the tick lists when you start, then it just makes it easier for everyone. So moving on to not signing checklists. This is kind of what I just started with. Occasionally, a shift gets busy and you forget to sign a checklist for something you've done, or you sign a checklist thinking you're going to do it and then run out of time to do it. So both of these are detrimental. If you don't sign the checklist and you've done the task, then that means that the next person that's come onto the shift might start doing that task and then halfway through find out actually it's been done and it's unnecessary. It could delay other work if you haven't said you've done the QCs, so they rerun the QCs. The opposite of that is obviously if you have signed it off to say you've done it and then you haven't done it, it means we could go without having QCs in place for half the day. So it's really important that you're paying attention to what you've done. Don't sign checklists if you haven't done it. If you have done the task, please try, just before you leave, just have a quick flick through the checklist and just be like, oh yeah, I did do that, I almost forgot. It's always a good practice to check the tick lists when you start and when you end your shift, and obviously throughout the shift if you're filling them out, just to make sure that everything that you have done has been properly recorded. And it's just common courtesy to the next person starting so that they actually know where they stand in the shift. Finally, missing details when booking him. So this is obviously something that normally happens when you're busy, you've got the phone going off, you've got someone talking to you, you're running around because you've got something else going on. Everyone does it. It's really easy to do, but it's still really important that we are checking and second checking this work. If we end up transfusing a patient with, I don't know, one letter different in their name, it may not seem like a big deal, but you can have two patients on the same ward with the same name. So you could end up giving the wrong blood to the wrong patient just based on that small demographic issue. So checking and second checking, and even if you are the one that books it in, if you're the one that's authorising, you should be second checking what you have done. You shouldn't be trusting yourself, as silly as that sounds. That's where the errors occur, is normally when there's just one person in, so you don't have anyone checking your work. So just bear that in mind. And if you think you are too busy and you've got things that can wait, then leave them. If you've got antenatal work that can wait till the next day and you're running around because you've got someone bleeding and 3 panels to run, then take a step back, deal with the things that are urgent. One of the biggest skills in blood transfusion is being able to prioritise your work. So with all the errors that I've just mentioned, it's basically about slowing down, not making assumptions, and supporting each other. If you've completed your tasks and you notice someone else is busy, ask if you can help them out. And if you aren't sure whether something has been completed or how to do something, then ask someone else. So now we've gone through the CAPAs, which obviously not so much fun, we're going to focus on something that's happened recently-ish that has worked really well. So in this case, we're going to be looking at an RCI report that was received back on a patient who we had investigated for a query transfusion reaction. The in-house testing did not show any antibodies present, that's in the pre or post, or any incompatibility with either unit that was transfused. And the sample was only sent away because the DAT was positive. The BMS, who initially reported this result, did so following the correct protocols. So they added on the antibody as they should have, they updated the CXM flag, they did everything they were meant to, but they didn't pay attention to the previous information. So the information about the query transfusion reaction that we hadn't actually detected an antibody in-house, and therefore didn't actually highlight it. So the person who then second checked noticed that the patient had an anti-K detected at NHSBT that was not detected in-house, and then raised this to the transfusion practitioner. This meant that we could correctly report the new antibody to shot. So because previously we'd given this patient a KEL positive unit, we have technically been the reason that the patient has sensitized and created the anti-K. Therefore, they should be reported to shot. And it also meant that we could start an investigation into why we hadn't detected this antibody in-house, what was going on with our procedures. So by just spending a little bit of time, not just second checking the actual report, but second checking the previous, so going back up and checking what we actually got in our in-house testing, it meant that the BMS properly reported it and that we could investigate what had happened and hopefully prevent this happening in future. It really helped us to properly put procedures in place for next time. Right, so hopefully this has been interesting to everyone. I know it kind of seems a bit here, there and everywhere. Hopefully the more of these we do, the format will probably change as we go along. If you do have any interesting cases, then please let me know, or any of the seniors. And remember to do a reflection on this talk to get the CPD points for it. Thank you very much for listening. Bye!